In our previous session, we had discussed about the airfoil terminologies. Let us start off with airfoil data. During the late 1920s and into the 1930s, the NACA developed a series of thoroughly tested airfoils, devised a numerical designation for each airfoil, a 4-digit number that represents the airfoil section's critical geometric properties. It was developed by the National Advisory Committee for Aeronautics. The shape of the NACA airfoil is based on the series of digits. There are a variety of airfoil present, and there is no single airfoil that will create a better lift than the other. The amount of lift that an airfoil creates depends upon the angle of attack, speed, and other flight conditions. Different airfoil work in different conditions. NACA 4-digit series. The first digit represents the camber in the percent chord. Second digit represents the location of the maximum camber in tenth of chord. Third and the fourth digit represents the thickness of the chord. Let us see an example. The NACA 4526, which looks like this. The maximum camber of 4% of the chord located at 50% chord back from leading edge and 26% thickness. So hence we have 4% which represents the first digit, 50% which represents the second digit, and 26% thickness which represents the last two digits. Another series is the NACA 5-digit series. The first digit multiplied by 0.15 gives the lift coefficient at ideal angle of attack. Second digit multiplied by 5 gives maximum camber from leading edge in percentage. Third digit indicates whether the camber is simple or reflex. The fourth and the fifth digit represents the maximum thickness of airfoil. The example is NACA 23112, which looks like this. The lift coefficient of 0.3. So the first digit 2 into 0.15 gives 0.3, which is the lift coefficient. Maximum camber located at 15%, we get the second digit into 5 chord. Reflex camber, which is 1, and if it is a simple camber, then it will be 0. And maximum thickness of 12% from the chord is the last digit. Now, an exercise for you people. The link is given below, which contains a series of NACA airfoil and their details. So find the details of different airfoils and how they are distinguished between one another. Create a tabular column as shown and enter the details respectively. The NACA series for you are NACA 1016, 4412, 23112, 0021, 22112, and 0006, and all the NACA series are at Reynolds number of 1 lakh. This is the tabular column. The first column has NACA series, that is the number. Then find out the maximum thickness, at what percent of the chord is the minimum thickness, at what chord, again maximum CL by CD, at what angle of attack, and the type of airfoil, whether it's a symmetrical or a cambered airfoil. The answer for the exercise will be given at the end of this chapter. I hope you would have understood today's session. Let us move on to the lift curve and pressure distribution curve in the next session. Thank you.